So I was playing with these coils and my Royer oscillator, and one of those coils is the inductor, and with 9 volts on this battery makes these UV lights go on, makes these other lights go on, and that's theoretically a 12 volt board. It's only pulling like 0.2 amps from a power supply, 6 volts, which 12 volts at 0.2, so 0.6 watts to drive all those LEDs and those, and it's just a few of these coils and my Royer, but my scope is only using, like, this is one side, that's where the load mostly is, this is the other side that's being unutilized. There's no bring back when it's an air core. And if I measure that wave, that's 72 kilohertz. And I have a capacitor here under, that's my capacitance for my coil, for my Royer. And the inductance just has to be high enough to support the current draw. Oh, I'm sorry, this isn't a Royer, this is a Mozilli. Mozilli. Okay, so I was trying with this coil and not having as much luck with my Royer. I'll hook that up. Okay, so I lied. This one is 18 kilohertz for the same capacitance, and I sort of broke my load. So with this load connected, my frequency drops to about 1.8 kilohertz, and on the opposite side I have a spike of almost 400 volts opposing that, and that's 0.2027 and almost 12 volts. Earlier I was demonstrating this coil. This large one's still hooked up, and my spike looks like that now instead of what it was looking like before. That's running a load. I don't know, it's not a nice, graceful shut off. I have a, oh, maybe I had that before. Okay. I'm not sure what the quality of this circuit is. I know that this one had a very low voltage buildup. I don't know if it's the gauge of the wire. This is actually thinner and fewer turns, but it had a much better voltage buildup. I was able to get the counterwound toroid. This is descending counterclockwise. That's descending clockwise. With an air induction, this one doesn't really want to pick up. I'll try and prove that later. It'll probably disprove me at that point, but I'm pretty certain that that's the case. So I have this scope connected across current sense resistor here. It'd probably be more stable if it was on the ground side instead of the power side, but I have this long tape of LEDs my rotor oscillator, and a 9-volt battery with my scope, with my thing attached here. So I have 0.18 amps and a 9-volt battery, lighting those, for 170 milliamps. The scope shows a big voltage spike still. The current give it a little more voltage. So I'm at 12 volts. This is the current sense resistor. It's 50 millivolts. And you can read that later. So that's 100 millivolts on a 1-to-1 scale, and it's a very periodic pulse. So I'm pretty sure it follows this voltage pulse. I should probably focus on these things. And just an arbitrary capacitor here. At 12 volts, these are very bright, all of them. They're in series, so there's two big ones that are in series, and then 2 little ones. So that's 1, 2, 3, 4, 5. This one didn't have a match pair, but it's 5 times 12, 60 volts, milliamps for microseconds, 5 microseconds, and 4 watts.